So a hypothesis testing here. A hypothesis is a statement made about the value of a population parameter. Okay, so it's a statement made, a kind of what we think. So a result of the experiment or the statistic that is calculated from a sample is then referred to as the test statistic. So we are understanding some of the vocabulary used here. So then we've got also introduction of the null hypothesis. This is the hypothesis that we assume to be correct, what is currently assumed to be correct. And then the alternative hypothesis is what we are challenging the current hypothesis with. It's what we are suggesting. It's a deviation from the norm. So the alternative hypothesis is essentially tells you about the parameter if your assumption is shown to be wrong. Okay, so this is the alternative hypothesis denoted by H1. Okay, so the test statistic, as we saw, is the experiment of this from the sample that we've carried out. Okay, in the hypothesis testing process, we assume that the null hypothesis is true, and then we either prove or disprove this null hypothesis using a certain significance level. Now, typically the significance level for hypothesis testing will be 10%, 5%, or 1%, but in a particular question we'll be told what this is. Okay, so there's the kind of two things that all the kind of vocabulary that we need to know associated with it. Critical values and critical region is the next thing that we want to kind of understand. So what is a critical value? Well, a critical value is the first value that will result in us rejecting the null hypothesis. Okay. So the first value that results in us rejecting the null hypothesis, i.e. it is the first value within the critical region. So here you can see the critical region is all the values 8, 9, and 10. And so the critical value will be the first value that results in us rejecting this null hypothesis. So the critical value in this case would be 8, for instance. Okay. We'll take a look at all of this in the context of a question shortly. So how do we then find out, how do we reject something? Well, it's dependent on the significance level. Okay, whatever significance level they provide, our value would have to have a probability less than that significant level. So in this particular example here, we had a 5% significance level. It was a one-tail test. And so if you take a look at this, when its probability of x is equaling to 7, it gives us 0.0425, and 0.0425 here is a value which is less than 5%. Okay, because that is, if you think about it in terms of percentage, if we turn that, that will be 4.3% or 4.25%, and that's less than 5%. So this is the first value that goes under the 5% test significance level, and therefore x equals 7 is actually our value that makes is our actual critical value in this case. Sorry, I should have, that would be our critical value. Okay, because it's the first value that is below 5%. Okay, so that's our critical value. So in this case, if our test statistic happens to be, and if we did a sample and it worked out to be that 7 of the, we got x to be 7 in our sample, then we would actually reject the null hypothesis because this value here is less than the significance level. So a two-tail test is whether you can either have less than or greater than the original probability for the null hypothesis. So in such a case, we will be given a significance level, but what we do is we halve the significance level and we test on each tail, on the lower tail as well as the upper tail, with half of the significance level. Okay, so that's how we could do it. We can also double our calculated probability to obtain the p-value. So whatever we get for our probability, we double it to get the p-value and compare this with the significance level of the test.